In this video, I'll solve this question about torque on a teeter-totter. So the first thing I did was drew a picture and then made a list of our knowns and our unknowns. We actually have three parts, part A, B, and C, so I put RA, RB, and RC as the three different distances that go here with the force. And then what we're looking for is angular acceleration A, angular acceleration B, and angular acceleration C. Let's see. Torque is RF sine theta. Okay, definitely I have an R and an F on this side. Sine theta, what would theta be here? R is there, F is there, so 90 degrees. Sine of 90 degrees is going to be 1. That's nice. Over here, I've got R, and then my force is the gravitational force on that child. So, I should be able to calculate the net torque around that point. So, net torque is the torque from the child plus the torque from the adult. And that is torque from the child, mg r child. And the gravitational force is going to push that way, so that's this direction. That's clockwise, so that's negative. That's going to be a negative torque. The adult is applying a force this way, so if the adult applies a force that way, it's going to try and turn it this direction when it's positive, so plus force applied times that R, which is either going to be A, B, or C. Net torque is I alpha. The only mass we have to worry about here is the mass of the child. So remember, for a point, I is just mr squared. So torque is m child r child squared alpha. So now we can set this equal to that. What we're looking for is alpha, so we divide both sides by this. Are the units going to work? This is force times a distance. So force, that's kilogram meters per second squared times the distance. That's squared. All right, so force, that's force. Yeah. So on the top we have this. On the bottom we have kilograms times meters squared. Kilogram meters squareds are going to cancel. So this is going to be 1 over second squared. The units for angular acceleration are radians per second squared. And if you remember, radians appear and disappear in these. So this actually is the right unit. So this is going to be radians per second squared. All right. So it looks like we haven't made any mistakes. So alpha is 95 newtons. So let's do for A. Alpha A, 95 newtons times RA, 3 meters minus 16 kg times 1.5 meters times 9.8 meters per second squared. It's mg divided by 16 kg times 1.5 meters squared. 1.38 radians per second squared. So that's alpha for A. So that's a positive number, which means counterclockwise. So now you can do it for B and C. all you have to do is, instead of using RA here, you put in RB and RC to see what happens on the other two.